Hello, everyone, and welcome to our webinar, Simplified Namespace Management, the Open Standards Way, brought to you by the SNIA Cloud Storage Technology Initiative. This is Michael Hord, your host and facilitator for today's discussion. I work for Intel, and I serve as chair for the SNIA Cloud Storage Technology Initiative. Today's conversation is with David Slick, who serves as chair for the SNIA Cloud Storage Technical Working Group. Hello, David. How are you?
Hello and good morning. Good afternoon to everyone who's joined for today's discussion.
Awesome. Yeah, before we get started, I want to mention that SNIA is a group of about 200 industry-leading organizations comprising of 2,500 active contributing members and 50,000 participating IT end users and storage experts worldwide. As one of the organizations within SNIA, the CSTI is dedicated to education and promotion of cloud storage technologies like AI at the edge, storage security and management, as well as driving understanding and collaboration among other industry associations. Before we get started, let's take a quick look at the SNIA legal notice. This provides SNIA's copyright notice regarding use of the material. There are no warranties expressed or implied, so if you want to reference this material, please do so at your own risk. You can download a copy of this presentation using the interface for this live webinar. The interface also allows you to submit questions during the talk and rate this presentation at the conclusion. We really appreciate your questions and feedback. For today's discussion, we will learn about data storage namespace management. We will explore concepts and challenges around namespace management operations, as well as review what is ISO standard Cloud Data Management Interface, otherwise known as CDMI, and provide examples of how open standards may be used to overcome some of the cited challenges. A reminder, please submit questions at any time during the presentation. If we're not able to cover all the questions during this session, we will answer your questions in a Q&A blog, which will be posted after this webinar. So let's get started. David, please take it away.
Thank you. So we're going to start out with a brief overview of namespaces in storage systems. So the term namespace is somewhat overloaded, used in different contexts and different parts of the computing and storage industry. When we look at the SNIA dictionary, which is an excellent resource for definitions related to this area, there are 4 different definitions. The more general definition for namespaces is just a domain of identifiers. In file systems, it refers to a set of valid names that are recognized within a file system. In a management context, it refers to collections of object definitions and instances. And in NVMe, for block storage, it represents specific formatted storage that can be accessed by a host. If we take a step back and say, well, what's the commonalities between this and how are they used in a more general sense? Namespaces are uniquely identified groups of locally unique identifiers, which enables them to be globally unique. So let's unpack that a little bit. So if you have, for example, a file system, and you have a file in that file system, and that file is named readme.txt, that is locally unique within the context of that file system. But just the file name, readme.txt, is not globally unique. In order to make that globally unique, you need to be able to differentiate it from another file, also named readme.txt, that exists within a different file system. The concept of namespaces says that even if you have the same file name in 2 different namespaces, the combination of the namespace identifier and the file name are globally unique. So you can think of namespaces as a way of grouping resources such that they can be globally unique. So why do we need namespaces? Well, there's several reasons why namespaces have developed in the industry. One reason that they've developed is to be able to do grouping. And grouping isn't just important for unique identification. Grouping is also important for being able to manage all of the entities within a group as a single thing that you manage. For example, I don't know how many of you have experienced this, but it's fairly common. If you try to copy all of the files in a file system, that will take significantly longer than just copying the underlying volume that contains that file system. That's because when you deal with objects on or files on a file by file basis, the computer has to do significantly more work to copy that than to just treat all of those files as one single entity that can be copied at block level. So that is one of the advantages of namespaces, is that you can manage a whole group of things as one entity. The second advantage is that uniqueness property we mentioned earlier, in that two different file systems can contain a file with the same name, or two different object stores can contain an object with the same identifier, or two different block storage systems can contain LUNs, etc. The final advantage for namespaces is delegation. We can say that a given namespace is managed by a given storage system, endpoint, or other cloud system. So as an example for that, that lets us create more efficient ways of being able to route transactions and distribute the load, because we can say preferentially storage IO going to one system, so one namespace goes to one system, and going to a different namespace goes to a different system. And that could be configured and routed to balance load across different infrastructure. So those are the three primary reasons why namespaces are used in the storage industry. So let's go and let's look at how namespaces can interact. Of course, the base case is where you have disjoint namespaces, namespaces without interactions. Here in the diagram, we see a blue namespace here and a red namespace. And these namespaces are completely isolated. You can access resources in one or the other, but there's no traversal from one to the other. When you set up namespaces to be nested within each other, we usually refer to this in the file system world as mounting. You now are able to access, for example, the red namespace from within the blue namespace. So if you start at the root of the blue namespace, you can CD into or access files in the case of a file system. You can access resources that are within the blue namespace, but you can also go through what is known as a mount point that allows you to traverse from the blue namespace into the red namespace. From the perspective of clients, this is often transparent. So a user in an application doesn't see that they're necessarily crossing a boundary between namespaces. They just use the standard mechanisms of the file system or object store to transparently go from one namespace to another. In addition, we commonly see a new technique called overlaying namespaces. This is shown in the third diagram here, where the red namespace is overlaid on top of the blue namespace. What this means is when you go to access resources, the system first checks to see if the namespace that's being overlaid on top, in this case red, has any identifiers that are the same as resources within the namespace that is being overlaid on top of, in this case blue. Accesses will preferentially go to the overlaid namespace, and if resources don't exist, they'll fall through to the underlying namespace. So in this case, if a user accessed that top resource there, it exists in both the blue namespace and the red namespace, so the resource in the red namespace would be used preferentially. If the user accesses the resource at the bottom, it does not exist in the red namespace, so it falls through and the resource in the blue namespace is used. This is most commonly used in containerized systems where you may have a base namespace that is your default operating system image, and then an overlaid namespace on top of that, which contains specific resources, configuration, changes to system software required for running that specific image. This can be a very powerful technique and is another example of how namespaces can interact. So if we go into a little bit more detail about imports and exports for namespaces, we introduce the concept of an export in the middle example here. The red namespace has a resource. The little inward arrow here represents an export. That's a location inside the namespace that can be mounted into another namespace. In addition, when you want to connect namespaces together, you need to create the concept of a mount. This is a resource within the blue namespace where an external resource is going to be mounted. Once that mount operation is complete, as you can see in the diagram on the right, the two are connected together. This can be, of course, more complicated as you introduce more capabilities. For example, on the left, a namespace may have multiple different exports in different protocols. For example, here we see a scenario where the root of the red namespace is exported via the NFS protocol and via the SMB protocol. In addition, another resource within that red namespace may be exported via iSCSI as a block device. A given namespace, in this example, the red namespace, may be mounted by multiple namespaces. In this case, we have the purple namespace and the blue namespace, both mounting the red namespace from the same location. In addition, namespaces may even be mounted into themselves. Here we have a scenario where we have part of the namespace / apps within the red namespace that is exported, that has then been mounted underneath each home directory inside that same namespace. So a user can just go and look at /apps within their own home directory. So that's an example of where you may have mounts that go from a namespace to itself. Okay, so let's just quickly recap. The key concepts with respect to namespaces are collections of entities. Namespaces can export entities via protocols. Namespaces can import entities that are exported, and these can be mounted into a new empty entity defined in the importing namespace, or can be overlaid onto an existing entity in the importing namespace. Okay, now that we've gone over this introduction to namespaces, let's spend a little bit of time talking about some of the challenges of namespace management that we've been seeing in the cloud. Okay, so one thing that makes it very challenging for a client that wants to do namespace management is that different types of namespaces are often managed using different protocols. LUN management, NAS management, and object storage management have very different interfaces. And in addition, different vendors often have different interfaces for managing as well. So even if you have two different object management systems in the cloud or two different NAS systems, the mechanism by which a client can go and specify, how do I want a namespace to be exported? How do I want a namespace to be mounted? How do I want to connect these together? Often requires vendor by vendor and protocol by protocol interfaces. This is a significant challenge for clients because if I want a client to be able to discover, navigate through, specify my exports, specify my imports, and manage the lifecycle of these relationships, I have to be able to understand all of these different protocols and all of these different vendor-specific interfaces. And if over time new vendors software is introduced, new cloud services are introduced, etc., my client has to be updated to be able to understand these new interfaces. Some examples of the actions that a given client may want to perform for managing namespaces include, as a client, I want to export a directory in a file system as an NFS share or a SMB share, etc. As a client, I want to mount an NFS share into a file system. As a client, I want to export an ISO image or a VMDK that's stored in NAS namespace as an iSCSI LUN, for example. Or as a client, I want to then mount an iSCSI LUN as a file system into an existing file system. Or if we're looking at object storage, I may have an S3 bucket out in the cloud or on a storage system, and I want to mount that. Or conversely, if I have a S3, I have a directory and I want to make that available via S3, I may want to export that. So there's lots of different permutations here. Wouldn't it be nice if there was a standard way to do all of these? One that took into account security across all these different protocols. One that was out of band with respect to the data protocols themselves and declarative and easy to implement for both the servers and clients. Well, this is one of the primary use cases for the SNIA Cloud Data Management Interface, the CDMI standard, which we will dive into in more detail in the coming half hour.
Hey, David. David, we have a
Yes.
question, and this question has several layers, so we probably will treat some of this in a Q&A blog. But the question is, if you could just talk briefly about the difference between a normal namespace and SRIOV enabled namespace. Sorry for the echo there.
Not a problem. Okay, so I see the question here. The question is, how are queues assigned to individual namespaces and how can we customize them? What is the difference between normal namespaces and SRIOV enabled namespaces, and also about set domains and endurance groups? So these are some specific questions related to NVMe namespaces. In this presentation, we're talking a little bit more generically about namespaces as an abstract concept, but we will talk a little bit about NVMe later on in the presentation. So I will answer part of this at that time, but part of this is also outside of the scope of this presentation, since as a cloud presentation, we're looking more at how does this look to the consumers of this as a cloud service rather than the underlying infrastructure. So there is some interesting kind of plumbing that has to be done. For example, if you wanted to use CDMI to manage NVMe namespaces being exported, say over NVMe OF, within a cloud environment, you would need to coordinate a number of the parameters for the NVMe namespace and make them available. And CDMI provides a generic mechanism to do that. And I will point that out as we walk through that. So thank you very much for bringing that up. Okay, so let's jump into a brief overview of what is CDMI. So CDMI is the Cloud Data Management Interface. It's an open ISO standard as standardized as ISO IEC 17826. It's on its third ISO revision. Official standard version is CDMI 2.0. And the purpose of the CDMI standard is for managing data namespaces. So CDMI, while you can use it for data introspection, is not primarily intended as a data access protocol, like what, for example, S3, NFS, and iSCSI provide, but rather it is a management interface. It is HTTP based. It is a standard where everything is optional. The only thing you have to implement in CDMI is saying what you do and do not support. This reduces the amount of implementation complexity for vendors and for clients in that they can A, only implement the parts of the standard that are relevant for their application as a vendor, and B, as a client, they can discover what capabilities the vendor has implemented to determine what can be done through the CDMI interface. So some of the key capabilities of CDMI are the ability to discover, traverse, and introspect namespaces. We will give an example of this shortly. CDMI supports block, file, and object namespaces. Plus, it's designed to be future-proof for emerging graph and table namespaces. CDMI supports rich metadata, including declarative hinting for storage providers. For example, through CDMI, a client can specify out of band that they require special storage services for a given resource, whether that's a LUN, an object, or file. In addition, CDMI supports advanced storage functionality, including access to versioning, snapshots, bulk jobs, queues, and more. And CDMI supports namespace exports and imports, which is what we will be focusing on in today's presentation. So here's a very quick overview of what a CDMI operation looks like. If we look at the HTTP transaction shown on the right, we see that we have a get to a resource called /volumes. That URI there can be any resource that can be represented through HTTP. What happens is CDMI sits on top of whichever protocol you have, whether that's an SMB URI, an HTTP object URI, or a LUN access. You can put in a UUID or other identifiers into the URI, and you're specifying via the accept header in HTTP that instead of accessing the actual data itself, instead what you want to do is you want to get a different representation that is either a CDMI container, if you want to treat the resource as a container, or a CDMI object, which is if you want to treat it as a discrete object. If you're looking at it as a container, you're interested in what are the children and the properties of that resource. If you're looking at it as an object, you want to see information about the data itself. CDMI then responds. In this case, it comes back with its content type is a CDMI container. And if we look at the JSON body that is returned, it tells us some information about the resource. It gives some metadata. In this case, we're just showing the access and creation time information. But CDMI defines a whole series of storage system metadata, data system metadata, and user metadata that can be specified. So one of the applications of CDMI is you can put arbitrary tags associated with resources. So it's also a tagging interface. And you can also put declarative information. For example, if you wanted different levels of protection or different QoS, etc. CDMI provides definitions for that as well. So I would encourage you to go take a look at the CDMI spec if you're interested in more details on the metadata. We have a link at the end of this presentation where you can go and access the full spec. Okay, but what's specifically interesting here is we get a list of children. So in this case, if /volumes is our root, the list of volumes here, the children of the volumes container, each represent a given volume. So if we go and we take a look, we've discovered now the list of volumes. Let's go and look at the pi namespace that we discovered here that was at the end of the list. So what we do now is we go and we do a get for that /volume/pi, just appending that child name to the object name allows us to discover the URI to go and access the resource for that. So this allows you to introspect individual namespaces. You can see extended metadata about the namespaces. And if we notice here, that we have an import. And this is telling us that pi under volumes has been imported, in this case via SMB, from a remote server into that location. So we have now discovered that we have a namespace traversal from one namespace to another. We can see metadata about where that namespace is going, and this allows us to inspect namespaces in a consistent way. So now that we've determined that we can identify namespaces, enumerate them, find properties of them, traverse through them, how can we start to actively manage namespaces? So for imports, as we saw earlier, there is metadata that specifies that you can import a namespace into a given location. Here we see an SMB mount. So if we wanted to create a new mount to import a namespace, we would go and we would use HTTP to create a new resource, a new CDMI container. We would give it a name, and we would specify metadata saying that we want to import from, if we're still wanting to use SMB, from this remote server that we want to pull in this volume. And CDMI is able to use the credentials that the user specified, either directly or indirectly, to then go and mount that resource. So this has the advantage that if you've configured the CDMI server with credentials mapping, the user doesn't have to directly specify credentials. So the credentials for that SMB mount don't have to be stored on or sent over the wire in order to create that mount. Of course, if you want to encapsulate and tunnel the credentials, there's provisions in CDMI for that as well. So there's two different ways this can be done. Currently, the CDMI specification supports references via URIs, but we are currently working on enhancing that by specifying this JSON container here, the JSON object that allows you to specify imports. So if you are interested in contributing to this area, please join us, the SNIA Cloud Storage Technical Working Group. We're always welcoming interested parties to come in and assist us in further standardizing this functionality. With respect to exports, it's a very similar mechanism. You go into a given namespace that you'd like to export. This could be a directory in a file system. This could be part of an object store. This could be a LUN that is represented as a file, or as a listing of LUNs that represent objects in a fiber channel or NVMe storage system. So CDMI would then allow you to attach metadata to a given resource to say that you want that exported and how you want that exported. For example, in the diagram here, we see that we want an S3 export, and we want to have that directory exported as a bucket named testing under an endpoint example.com. And this interface allows you to have multiple exports. So you could have that directory exported via NFS, you could have the directory exported via SMB, you could have the directory exported via S3 and WebDAV. All simultaneously, you would just have 4 different entries under exports, all of which can be visible and configured. So we have a question. How do the responses behave if the responses are very large? Can I just get the metadata? Might it warn me if there are 70 billion objects and I really don't want to get all of them? That's a very good question. So CDMI has 2 mechanisms for this. The first mechanism is you can use query parameters to say, I'm only interested in very specific information. Say, I only want to list the exports for a resource. Or I only want the first 100 children. Or I only want the number of children, so I can decide if, whoa, there's 70 billion of these. I'm going to need to have a different mechanism for this. So that is one mechanism that CDMI supports for dealing with very, very, very large lists of namespaces and of objects. In addition, you can set up what are called queries, which is a more advanced way of listing the content of a CDMI namespace. And for those, you can have cursors and all the fun mechanisms if you want to traverse through, for example, an entire file system where you're wanting to process and get metadata. So those are two mechanisms that CDMI supports to mitigate that common challenge. And once again, I'd recommend for you to take a look at the CDMI specification, which goes into more detail on the ability to use query parameters to request specific fields and the ability to use queries to list and iterate through very large result sets. Okay, so CDMI currently supports, specifies how to export via NFS, SMB, iSCSI, WebDAV, and Aki. And we are currently working on specifying S3 exports. If this is something you are interested in, participation is welcomed. If you're interested in other export protocols, CDMI standardization is typically performed using what we call extensions. So interested vendors who are looking at adding functionality to CDMI will attend, work together with the technical working group to write up an extension document. The extension document is then sent out for public review. Once we have at least one conformant implementation demonstrating the extension and that implementation conforms to what's documented in the extension, we add the extension as an annex to the CDMI specification. And once we have two demonstrated interoperable implementations that conform to the extension, we merge the text from the extension into the specification itself. And this has been the process by which we have added many functional areas to CDMI, such as versioning started out as an extension. We got us another single implementation demonstrating that. It went in as an annex, and then two implementations, and that allowed us to merge it directly into the specification. Okay, so what about data objects? So we showed the concept of a container where we had, for example, a directory we wanted to export as a S3 bucket. What about a VMDK file that I want to export as a LUN via iSCSI? Well, the process is the same. The difference is that instead of wanting to manage this as a container, we now want to manage this as a data object. So we changed the content type. So before we had accept application CDMI container, now we have application CDMI object. And this tells CDMI to kind of switch modes. Instead of managing as a container, we're now managing it as an object, data object. So same process, we attach exports metadata to the object. In this case, we're specifying that we want to export this as iSCSI and that we have our various metadata we want, how we want to export that. There's a whole bunch of different parameters that can be specified for iSCSI exports that are detailed in the CDMI specification. And then we could, of course, turn around and mount that iSCSI export as an import if we want to pull that in as, for example, a file system. This can also work with other block type devices. So I will talk about that in 1 minute. So what is the current state of CDMI namespace management in the specification today? That's the version 2.0 of the specification. Well, we support exporting a container via NFS, SMB, and WebDAV. And we support exporting data objects as LUNs via iSCSI and Aki. The following operations are currently being added as extensions to CDMI. That includes exporting a container via S3, active standardization work ongoing for this. and being able to import containers via NFS, SMB, S3, and iSCSI. In addition, the CDMI standard is designed to allow us to extend it in, for example, exporting objects as LUNs that are offered over Fiber Channel, or exporting NVMe namespaces via NVMe over Fabric, say, for example, using RDMA. So, for example, one could envision a traditional storage system that is purely working within the Fiber Channel or NVMe domain, that's using the Swordfish management standard behind the scenes for managing all of the storage resources, that wants to then offer a more cloud-like interface for namespace management. That storage system could offer a CDMI interface that allows a user to authenticate over HTTP, list the available LUNs, and then specify how those LUNs are exported. So this is an example of where CDMI can be used, even kind of outside of the more traditional cloud domain, to manage more enterprise style LUNs via Fiber Channel and NVMe over Fabric. And of course, there's the blending in various cloud infrastructures. You want to be able to do this too, because you want to be able to orchestrate and coordinate how your LUNs are connected to various clients, with CDMI being an excellent way to integrate between your orchestration layer and your storage provisioning. Okay, so just to give a quick recap of the benefits of CDMI for namespace management. The primary benefits are CDMI provides a single protocol for namespace management. It enables client namespace management operations using a simple HTTP-based protocol. Vendors and clients only have to implement the required subset of the standard. It supports block, file, object, and is extensible to graph and table. It's an open, vendor-independent standard, and vendors can add extensions for new functionality. So we'll end this section with a call for participation. If you are interested in using the CDMI standard in your project, here are some resources. We have a full version of the specification up on the SNIA website. You can read that there. In addition, you can learn more about CDMI at the SNIA website under /CDMI. If you're interested in working on standardization or have technical questions you would like to ask, please join us at the SNIA Cloud Storage Technical Working Group. And if you're interested in creating a CDMI implementation, we can help with any guidance that's needed there. If you're interested in extending CDMI, here is a list of, under public review, of the existing CDMI extensions, and you can add a new one. And if you have a CDMI implementation, please join us at a PlugFest. Depending on demand, we have been holding these at SDC. And please give us feedback on the standard to cloudtwg@snia.org. Okay, so
David, there's a few questions. Yeah, there's a few questions they put in the chat at the bottom there.
Okay, so we have several more questions. So first question is, where can I go to get help using CDMI with my application? Okay, well, we have a couple of resources, some of which I mentioned here. We would encourage you to join the SNIA Cloud Storage Technical Working Group. We provide assistance and guidance there. In addition, SNIA has a GitHub site, which we did not mention here. You can open issues there asking questions around the specification, and we will be sending out that link as part of the blog entry associated with this talk. So you'll be able to get that there. Okay, second question. If I'm not using CDMI, what tools and methods would I need to incorporate to do the same kind of operations? Well, as I mentioned, each different vendor's storage system generally has a different management interface by which to accomplish namespace operations. So for example, if you're using Google Cloud or AWS S3, for example, you would be using RESTful API calls specific to each of those services to, for example, provision new buckets and managing those buckets. If you're using a traditional NAS platform, for example, a NetApp filer, you would be using their ZAPI, now RESTful interfaces to, for example, provision volumes and export them or manage NFS and SMB shares. Different vendors would have different interfaces there. And each vendor provides their own tools and methods. And as a client, you would need to understand and implement each of those. Okay, and then the third question is, how does CDMI help address security in namespace management? Oh yeah, that's a really good question and one we could probably do a whole presentation on, but I will try to give a very, very quick overview of how CDMI deals with resource and namespace security. So CDMI is meant to largely be a switchboard with respect to security. So when you have a client connecting in via CDMI, it's going to present credentials. Whether the credentials are through a directory server or whether they're through an underlying identity management system, etc., CDMI receives those credentials. It looks at what resource is being specified, and then it delegates those credentials out to an underlying system. So for example, if you're using Active Directory, you may delegate to Active Directory. If you're using a specific system for example, management access, you may be delegating out to that, etc. So the advantage here is you may have two different resources sitting beside each other in a namespace, each under the control of a different security provider for authentication. So CDMI generally just redirects and then comes back with a receipt from the authentication provider information about, is the principal authorized, are they are their credentials valid, etc. CDMI then allows you to have ACLs using the standard ACL model associated with resources. So then you can look at the principal and say, okay, this person's allowed to manage, this person's allowed to read, this person's allowed to modify. So for example, exporting a namespace would require the user to have sufficient permissions to be able to specify the export namespace. So with respect to security, CDMI provides that common switchboard that allows you to have one interface, one set of credentials that can then get directed to the corresponding backend, which is really important if you're using CDMI to connect together many different namespaces and many different resources from many different underlying storage systems. For example, if you're doing hybrid cloud, where you have some on-prem resources and cloud resources from different vendors, you can then have one set of credentials that get mapped between them. So if you have more questions about CDMI security, please don't hesitate to forward them to the Twig, and we'd be happy to elaborate on this further. In addition, there's a section in the CDMI specification under domains, which talks about how this switchboard, this redirection and mapping of credentials is accomplished. Okay, so do we have any further questions?
I think that that has the total list there.
Okay, so do you want to take it from here?
Sure. Yeah. Thank you, David. Could you go on mute and see if that helps with the echo. Okay, perfect. Great. Thank you so much, David. That was totally awesome, and just really appreciate your expertise and insights. This has been a great discussion, and I really appreciate your time and effort on all of this. And so thank you to our audience. Thank you for joining us. Please remember to rate this webinar, as this is very important to get your feedback, which helps us create better educational material. Also, please remember, you can always download this presentation and many other items at our educational library, as well as follow us on Twitter. Thanks again to all for the effort, and have a great day.